welcome back. So this is mass expert video tutorials, and we are still getting through under the hypothesis. So on the first video, that is you being introduced to the introduction to what? To the hypothesis what? Texting. And we look at the null hypothesis, the type of what? Hypothesis, that's the null hypothesis and the alternate hypothesis and all that. Alright, so now that we are here, hypothesis testing of one sample what? One sample. So we are going to look at hypothesis testing of one sample before we go to hypothesis testing of what? Two sample. Alright. But with both the one sample and the two sample, we have it in case it's dealing with what? Means. And in case it's dealing with what? Proportion. So let's see the requirement of something that we need in order to get there. Alright, good. So that is why I have the topic here to be hypothesis testing of one sample. One sample. So with this video, we are going to combine what we need in order to get to the mean and the what? And the proportion. Alright, you will have it, trust me. Alright, so the test statistics. The test statistics. So the test statistics, the one for proportion, the one for proportion, and we have the one for the mean, and we have the one for the mean. Alright. Now, with the mean, we have it in two types. So I will call this A and I will call this B. It's like when we're dealing with confidence interval. We have the case where the standard deviation is known and is not known. So you know the difference between these two. We have the sample proportion. Sorry, sample population, and we have the population proportion. That one is there. Alright. What I mean is the one dealing with the X and the one dealing with this. Good. Make sure you have watched the previous video. Alright, so that's that. Good. So now, the one for the proportion, we are going to have our Z test or our Z score formula to be P hat minus P, all this over square root of P dot Q, all to the bracket of what? And please, the square root is affecting the N here. Alright, so alright, and we have the one for the Z test for the mean. That one too will be S bar minus the mean, all this over this, that is standard deviation. So this one will be the what? The population standard deviation, right? The population standard deviation. The population standard deviation. And the requirement you need in order to deal with this, you know it already, but I'll give it to you again. Alright. And we have this one too. Z is equal to S bar minus the mean. All this over S over square root of X. Alright, so looking at this is when we are having a large sample what? Size. That in this case, that is when the population standard deviation is known. The population standard deviation is known. So that is when this is known. So that's when this is what? Known. And this one, we have the is when this is unknown. So the case where the population standard deviation is unknown, that is when we go for. So if the population standard deviation is not given to you, then the sample standard deviation will be what? Will be given to you. Alright. So that is that. And we know that this one deal with the what? The large sample, and this one deal with the what? The small what? Sample. Alright. So that's what we have it there. Alright. Good. So we have this the test statistics now we are going to use to do whatever we are going to do. But we are going to pick each of it and deal with it so that you see how it's going to be like, and you will have it. All right. Good. I'll be back. All right. So now all that we want to do is that we want to see how we use all these tests in we are going to see how we use all these tests in making our decision and drawing conclusion, interpretations, and all that. So we are going to use this example to generate all these concepts. All right. Before we come back to the test on its own, picking each of it, the one for the proportion, the one for the mean, when the standard deviation is known, and when the standard deviation is not unknown, to deal with it. But I want to use this question to generate with you the concept of what you need for now. All right, good. So with this question, let's see. Don't forget what we have learned in the previous video. It will come in here. So we have a sample of 706 companies found that. So a sample of 706 companies found that 61% of the CEOs were male. 61% of the CEOs were male. So you see, even though I said I don't want to base or I don't want to tell you that I'm dealing with this test or dealing with that test, whether the population, the proportion, the mean, or whatever. But let's look at this one. Let's see the one that we can use to do this. Now, you see, a sample of 706 companies found that 61% of the CEOs were what? Male. So with this question, you can see that it's talking of what? A population. It's talking of what? A population. Because it's talking of a population of 706 companies. I hope you can see that. Alright. And it was found that 61% of the CEOs were what? Male. Okay. So here we know that we are going to use the one for the what? The proportion. We are going to use the one for the what? The proportion. The test statistics for the proportion is what I mean. Alright. But first of all, we need to come out with the claim. So what is the claim? In order for us to go for our null hypothesis and the what? The alternate hypothesis. So the question is that what is the claim here? So if 61, the claim is that if 61% of the CEOs were male, then most of the CEOs were male. Sorry, most of the CEOs are male. They are males. They are males because we have 706 companies and 61%. That means that out of the 100%, they are taking most of it. So the claim is that most of CEOs are male. Most of the CEOs are what? Male. Alright, so this is the claim. This is the claim in words form. So let's write it in mathematical form so that we write the opposite of it, and don't forget the steps. So this is the first step, the claim. The claim. So the claim, we know it's talking of what? It's about the population. So we are basing on the what? The proportion. Alright. Good. So most of the CEOs are male. Most. So most means what? Greater than. Most means what? Greater than. Now, okay, so it's going to be greater than what? That is what we are going to build on now. So now here, the percentage is, we don't know how successful it's going to be, right? So with this, our success and our failure should be 50-50. So here, we're going to 0 point, because the fact that you made a claim that you mean is true. So 0.50. Alright, so that's going to be the what? The claim. Then we write the opposite of it. Okay, so then we write the opposite of it. So the opposite of this is going to be what? We have done this already. Less than or equal to 0.510. Alright, then you indicate where your null hypothesis is going to be and where your alternate hypothesis is going to be. So looking at this, we know that the null hypothesis can be anywhere. So far as we have the symbol there, then that will be the null hypothesis. So looking at what we have here, this will be the alternate and this will be the what? The null hypothesis. Alright. So that is what we have there. So our null hypothesis is going to be B. So the sign which is less than or equal to will change to equal to sign 0.50. Alright, so that's going to be our null hypothesis. Then we go for the alternate hypothesis. And that one to maintain being greater than 0.50. Please be careful. Here is not going to be 0.61. No. This is a claim. So this is a success and the failure. Alright. Good. So now, after getting this, then we now go to the second point here. It's here that you understand where this is coming from. Okay? Alright. So the second step is the test statistics. Statistics. Alright. So we know that this is talking of what? A proportion. So that means that we are going to use the proportion what? Test statistics. So that's going to be B is equal to B hat minus B. All this over square root of B dot of U over N. Alright. So that's going to be our test statistics. Okay, so now we need to define all these that we have here. So looking at this, our N here will be what? Our N here will be 706. 706. Then what is going to be our failure and our success? So the success is going to be, that is exactly what you have. So that is 0.50, 0.50. Alright. So what is going to be our point estimate? Or we can see the P hat. That's our point estimate. So our point estimate is this. So this one we have here. I'm now going to specify it for you. This one we have here is the point estimate. So that's going to be our P hat. Our point estimate, which is going to be 61%, right? Which is the same as 0.61 by dividing 61 by 100. That's what you're going to get. Alright, good. So now, can we go for our test? Because we have this, we have that, we have that. So the rest is just substitution that we have to do. Alright, so let's go and do that. As I said, I want to show you how we make a claim, we interpret the results, making decisions and all that. So I'm just using this example to let you get the concept for that. Alright, so Z will be equal to, we know that our P hat is 0.61. I'm doing substitution to the formula. And the P is 0.50. Alright. And we have the P there to be 0.50 times 0.50. All this over the N. And the N is what? 706. Alright, good. So, having this, when you punch on your calculator, you are going to get 5.84. 5.814. Beautiful. Beautiful. So now, this result is the test statistics. It's a test statistic for the what? For the proportion. So our Z now here is the test statistics, which is 5.84. The test statistics. So this is the second point. So the third step is where we are going to see how we make what decision. So let's go and see how we make decision, and you will have it. I'll be back. Alright, so now these are our results, the null hypothesis, the alternate hypothesis, and the test statistics. Alright, so we are going to look at how we are going to make what? Decisions. How we are going to make what decision. Please, from this part, that is the most important part. Alright, because the other part is just using formula and you go. Okay, so now let's see how to make the decision. So the first thing to look at is the significant what? Level. The significant level, because you can't make a decision without a significant level, and your critical one interval and all that. In fact, it's something that is not ready. So let's move on. So the significant levels, we have the common ones, as I said. That's not the only ones, but normally what most persons normally use is these three: the 90%, 99%, and 95%. Alright, so we have the alphas to be 0.10, 0.05, 0.01. Alright, so this is the significant one level. Then let's go to the critical value. So the critical value is separating the rejection rating from the fail to reject what? Rating. Is you being it helps you to separate the rejection rating from the fail to what? Reject what? Rating. Alright. And in dealing with the critical value, you will need your alpha. So for instance, this alpha here, I'm choosing the 0.05. The question will be given to you though. Get that the one that we are using here from the question, I didn't give it to you because I first made you aware that I'm using that question to generalize something for you. Alright. So after everything, I'll bring a full question for you to see how it is. Okay. So now, this one, I'm using my alpha to be 0.05. And let's choose a z of 1 point. So if we have alpha of 0.05, then our z will be 1.645. You can read this from your table. Alright, good. How do you have it? That is area under the normal curve. You can do that there. We have already established these things already. Alright, so let's come to the rejection rating. The rejection rating is a rating that if our test statistics falls into we will fail to what? To reject the null hypothesis. All that is saying is this. Let's assume we have a z-score, and that is the critical value. We have it here. Now, what helped you to get this critical value? That is the alpha level. The alpha level of what? The alpha level of 0.015. So when you do that, here is your rejection rating, and here is your fail to reject what? Rating. Alright. So the shaded part is the rejection rating, and the unshaded part is the fail to reject rating. So this is what we are going to do. Be careful. I haven't used this, even though they are all ZZ, but they are not the same. The Z here is the one we use formula to derive. That is the test statistics. What I have here is the Z-score. Alright, or the critical value. So I'm now going to use my test statistic, which is Z is equal to 5.84 to make my what? Decision. Whether it's going to fall within the fail to reject region or the rejection region. Good. So this is what you're going to do. You know here is 1.645. 4, 5. Right? Good. So, if here is 1.845, then where do you think 5 point? Because here is 0, here is 0, right? So what do you think 5.84 will be? So you can see that 5.84 will not fall within here, but by 5.84 will fall on this side. That means that you are on the rejection what? Rating. That means that you are on the rejection what? Rating. So don't forget, this is where you do this. So you now use your test statistics, which is z is equal to 5.84, to check where it will be falling. To check where it will be what? Falling. Alright, so with this, we can see that we are going to reject the z-score, or sorry, the test statistics is going to be in the rejection region. Alright, I'll be back with, now, that's how we do that. We operate on the 0.05. So let me guide you on how to get 0.10, 0.01 and all that. Alright. Alright, now from what I just did, I was having my alpha to 0.05, right? And my z to be 1.645. Then I have the test statistics to be 5 point, whereas z is equal to 5.8. Alright, let me check. 5.84. 5.84. Alright, but you see, after getting these three, where are you going to? I mean, I want to draw my normal distribution. Is the normal distribution going to be on this side or this side? It depends. Okay? You may not know the reason why. That's why I'm coming with this three type of text for you to understand it. So I just want to reflect you back from what I have done. I chose this side, right? So my z came here 1 point. That is the critical value. Came here. I chose this side. But do you know the reason why? From what we are dealing with, from the question we are dealing with, I hope you know that our alternate hypothesis is H1 being greater than 0.05. Is that also? Our H1 or the alternate hypothesis is greater than 0.05. Or let me say, the alternate hypothesis sign is the most. That is, I mean that the alternate hypothesis sign is greater than just that. It's not about this value. It's about the what? The greater than what? Sign. That is why I chose the right hand side. So it's not always that it's going to be on the right hand side. It depends on the what? The text. So you can see that there are three types of text. Now, this is determined by the H1. Yes, it's determined by the alternate hypothesis. It's determined by the H1 because you can get an H1 which is less than or which is greater than. The emphasis, I'm repeating, the emphasis is not on this value. The emphasis is not also on this, but the emphasis is on the alternate hypothesis sign. Whether it's going to be greater than, less than, or not what? Equal to. So let's see the three types of text. So we based on the what? The alternate hypothesis to do this. The first test is the left tail. The left tail. When do we say we have a left tail? That is, if the H1 has a less than what? Sign. If the H1 has a less than sign, that means that we are the rejection region is in the left what? Tail. So you see that I'm having it in the left. So you negate your critical value. How do you are getting me? Go. I believe in you. You are good students. Alright. So that is what we have there for that. So this is the H1 having the what? A less than what? Sign. Now, B, the right tail. The right tail. That is if H1 has what? A greater than what? Sign. So if H1 having a greater than sign, that means that it's going to be what? At the right what? Tail. So the rejection rating is in the right tail because of the greater than. So the rejection rating will just be on the right side. Good. So that is that for that. So always you have to know where your alternate hypothesis, the sign that you are dealing with. Alright. The third one is the two-tail test. The two-tail test. The two-tail test, you see, that is when we are having the not equal to sign. So if H1 has this, then the rejection rating is in the both what? Tail. You are saying left toe, right toe. Then not equal to will be where? On both sides. So that means that if it's going to be on both sides, then let's say I'm having an alpha of 0.05. I cannot choose. We know that the alpha level is an area bounded by the rejection region. Alright. Then you cannot say here is alpha, here is alpha. But you have to divide this by what? 2. So that you can get the one for this side and the one for this side. So this side is going to be the negation part and this side is going to be the what? The positive side. Good. So that is that for the third type of what? Test. Please don't forget it. Always basing on the alternate hypothesis. Alright. You cannot use a null hypothesis to make your test. No, you can't do that. Alright. So that is that. That is that. Let's see example of what I'm saying. Alright, so now let's see an example of what I'm talking about. So all that I'm talking of is like this. For instance, let's say I'm giving an alpha of 0.05. Then our z is going to be what? Our z is going to be, that is 1.645. Alright, so so you are going to base on an alternate hypothesis. So the first one, you check the alternate hypothesis. So here the sign is what? Less than. It's not about the 0.5 here. No. It's about this. The sign is what? Less than. So that means that you are going to get something like this. So if it's less than, it's going to be the left one, tail. So the area will be in the what? In the left one, tail. So that means that, and on the left tail you negate it. So z will be equal to negative 1.645. I hope it's clear. Alright, so after this, if you have any z score, you use it to test where it's going to what? 4. Alright, good. Now let's look at another one. So even from the question that we are using to generate all these concepts, we had our z, which is the test statistics, to be 5.84, right? So with this, when you check, this is the rejection rating. And this is the what? The fail to reject what? Rating. And this is the rejection rating. Alright. So with this, then if this is your test, if this is your test, you use this one to check. Is it going to be inside here or inside here? You can see that this one will fall within this side. So this will be the fail to what? Reject. Alright. This will be on the fail to reject. Now, let's try the B. The B. That one, we have our alternate hypothesis to be greater than 0.5. Alright. So that means that with this one, the sign is what? Greater than. So the sign is what? Greater than. So it's going to be a right what? Tail. And if it's going to be a right tail, then you will not negate anything. So you just write your z-score. Write your z-score or the critical value there, 1.645, and that is that. And when you do that, that means that here is going to be your what? Your rejection rating. Your rejection rating. And here is going to be your fail to reject what? Rating. Then you use any test. It depends on the question. Because it's not always that the test that is going to be 5.84. I'm just using it as a clue for you. Alright. So now you choose, you check the 5.84. Is it going to be based on focus here or here? You can see that this one will base here. Because if here is 1.645, then 5 point something will be somewhere here. So this will be on the rejection of gradient. I'm still taking you through how to make the decision. Alright, so the next one is the C. The C2 is having an alternate hypothesis of good not equal to 0.5. So if it's not equal to 0.5, then let's see. Here we have to do something. We know that the alpha level given us is what? 0.05. Is that not true? Then when you sketch your distance, your normal distribution, you know that okay, so the not equal to, we know that it's going to be in the both what tail, both the left tail and the right tail. That's the negative z side and the positive one, z side. Alright, that means that you cannot say that the alpha level here is going to be 0.05. No, you cannot choose it for only that part. But we have to divide here by 2, divide here by 2. Okay? So we get alpha over 2 to be equal to 0.025. Yeah, 0.025. So this 0.025 is what you are going to write here. Z alpha over 2 is equal to 0.025. Z alpha over 2 is equal to 0.025. So that is what we are going to have there like that. Beautiful, beautiful. So with this, then you use this to what? To check your Z what? Text. Alright, so you know that here, the Z is not going to be this. Because the Z, or the critical value of which is 1.615, is the alpha level of 0.05. So you have to go for a new reading for this. Alright? And we know this already that it's going to be. So you negate it, negative 1.96. That's what the reading is going to be. And this is 1.96. Alright. So don't come and write 1.645 here, negative 1.645. No. When you do that, you are wrong. You are wrong because this is what? Left both tail. This is on the both tail. So we're going to get a new alpha level on both sides. So that's how we are going to do for such one question. Beautiful, beautiful. So this is how we make the decision. So in our next step, we are going to see how we go about by another method of making our decision. That is the V value.